Hello and welcome to Crazy Math Productions. Today we're going to be looking at graphing absolute value equations in the coordinate plane, that is two variable absolute value equations. So what we're going to do, we know that the absolute value, we've broken it down like this as before. Some particular things about absolute value equations. They're going to be V-shaped. Each one has a vertex. That vertex is at this point here. That's the vertex. You have two different options. If it opens up, the vertex is the lowest point. If it opens down, then the vertex is actually the highest point. What we're going to do, we're going to set aside x plus b, this part inside the absolute value, and that's going to be part of our vertex. And we plug it in, try to find the other part of our vertex, and then go up a few and down a few to give the table values for this. So here we're just going to find the vertex. What we're going to do is just set what's inside the absolute value equal to 0 and solve. Well, x plus 7 equals 0. Subtract 7 on both sides. X equals negative 7. Well, that's not all I do. I need an ordered pair for the vertex. I need x and a y. So I'm going to plug in negative 7 for my x. Negative 7 plus 7 is 0. So the absolute value of 0 is 0. And plug that in here. So x is negative 7. And when you plug it back in, we get 0 for y. Let's look at number 2. Again, set this part equal to 0. What's inside the absolute value? Set that equal to 0. We're going to solve by adding the opposite here. Get x equals 3. So that's part of my vertex. The other part we're going to find by plugging in. So y equals absolute value of 3 minus 3. Y equals, now 3 minus 3 is 0, and the absolute value of 0 is 0. So there's my vertex. Again, trying to find my vertex. I'm going to set just, now notice we have something outside the absolute value this time. We're going to set just the absolute value part equal to 0. I'm going to go ahead and solve. X equals negative 2. So that's part of my vertex. And now I'm going to plug it in. Negative 2 plus 2 is 0. The absolute value of 0 is 0. 0 minus 9 is negative 9. So there's my vertex. At this point in the video, I'd strongly encourage you to go ahead, pause it, try to see if you can do it on your own, and then see how you do. Okay, let's start. We're going to put the x minus 4 equal to 0, set that absolute value part equal to 0, and solve. X equals 4. So that's half my vertex. To find the other half, I'm simply going to plug it in. So y equals 4 minus 4, absolute value of 4 minus 4, then plus 5. So y equals 4 minus 4 is 0. Absolute value of 0 is 0. Y equals 5. So I plug 5 back in, and there's my vertex. Now we throw in something multiplied in front here. So let's try to go ahead and solve for my vertex. Find x, I'm going to plug in, I'm going to set apart the x minus 2 equal to 0. So I add 2 to both sides, and x equals 2. So there's half of my vertex. To find the other half, as usual, I simply plug it in. So negative 4 times. Absolute value of 2 minus 2 is 0, so absolute value of 0 is 0. Negative 4 times 0 is 0, and 0 minus 5 is negative 5. So there's my vertex, 2, negative 5. All right, same thing here. We're going to start by try to find our vertex. We're going to start by setting the x plus 6, the part that's in the absolute value, equal to 0. We're going to subtract 6 from both sides, and x equals negative 6. So there's half of my vertex. We're going to plug it back in. Y, separate these two problems here, equals 1/3 onto absolute value of negative 6 plus 6 plus 3. And negative 6 plus 6 is going to be 0. The absolute value of 0 is 0. And 0 times 1/3 is 0. So y is going to be 3. So there's my vertex. And once we have our vertex, we're going to go ahead and graph these. Now, all of these are a family of functions related to the base equation, y equals the absolute value of x. So what I'm going to do, just take my word on this one, but the base equation is going to look like this. Everything's going to be based on this. And you're going to notice later on in another lesson that you can actually manipulate this base equation and not even have to do a table of values, but we're going to start with the table of values, that particular method. All right, so number 1, again, like in the examples above, we're going to start by setting this that's in the absolute value equal to 0, and we find that x is 0. Quite simple. Now we're going to plug that in. Y equals the absolute value. Plug this in for x. The absolute value of 0 is 0. 0 minus 4 is negative 4. So I know that my vertex is 0, negative 4. So I'm going to start an xy table. And in the middle, I'm going to put my vertex, which is 0, negative 4. I like making a little box just to separate from myself and know that this is the vertex. Now, what I need to do is to choose one or two values larger than the x that we found for the vertex, and a few that are smaller. And we're going to plug each of these in to the equation. So y equals absolute value of x, and we're going to plug these values in here, then minus 4. Let's plug in, say, negative 2. So y equals the absolute value of negative 2. Negative 2 is 2 units away from 0 on the number line. 2 minus 4, 2 plus negative 4, they fight, the negative wins, and there's 2 left over. Now let's plug in the negative 1. Y equals, now negative 1 is 1 unit away from 0 on the number line, so the absolute value of negative 1 is 1. Y equals 1 minus 4 is negative 3. Now let's plug in 1. Now 1 is 1 away from 0 on the number line. We can keep, change, change. 1 plus negative 4 is negative 3. Let's plug in our last x value, which is 2. 2 is 2 units away from 0 on the number line, the distance, thinking distance. And 2 minus 4 is 2 plus negative 4. Negative wins, they fight, and 2 are left over. You follow lessons earlier, much earlier, from Crazy Math Productions, and we'll plug in here. So the basic idea is that we have these 5 ordered pairs, and you will notice that we have some very nice symmetry. These two are symmetrical. These two are symmetrical. So you notice that if you go equidistance from that vertex, then you're going to have equidistance from the y value as well. So it'd be a predictable pattern there. All right, 0, negative 4s. 0, 1, 2, 3, 4. That's my vertex. Now let's graph the rest of them in order. Negative 2, negative 2. Negative 1, negative 3. 1, negative 3. And 2, negative 2. And go ahead and use your straight edge, and it will continue from there. Same pattern. There we go, we've graphed one. Now I'd encourage you to go ahead and pause the video, see if you can do number 2 on your own. Let's see how you did. Again, we're going to set the whatever's inside the absolute value equal to 0. So in this case, x equals 0. Now I'm going to plug it in. Y equals the absolute value of 0 plus 3 in this case. Now, absolute value of 0 is 0. We're going to add that up. Y equals 3. So I'm going to put my xy table here. I think I can do a little better than that. My vertex is 0, 3. Okay, we're going to go up 1, up 2, down 1, down 2. And let's plug these in. So y equals the absolute value of something plus 3. Now that something is going to come from the x values in my table. So let's go ahead and plug those in. Plug in negative 2. Negative 2 is 2 units away from 0 on the number line. So y equals 2 plus 3 is 5. Let's try it again. We'll plug in a negative 1. Negative 1 is 1 unit away from 0 on the number line. 1 plus 3 is 4. Alrighty, we're going to plug in 1. The absolute value of 1 is 1 because it's 1 unit away from 0 on the number line. And plug in my y value back into the xy chart. Let's plug in 2. 2 is 2 away from 0 on the number line. And so I've completed my xy chart. And you'll notice that, again, these are symmetrical, these are symmetrical. What's going to happen is if you've plugged these values in correctly into this 2-variable absolute value equation, you should have this symmetry. That's going to happen every time if you've done it correctly. Let's go ahead and graph these points. 0, 3. This is my vertex. That should be the corner, if you will, of your absolute value equation. And now let's plug the graph or plot the rest of these points in order. So negative 2, 2, 3, 4, 5, negative 1, 4, 1, 4, and 2, 5. Make sure that when you're graphing these, you do put the arrows on the end. That indicates that it goes on forever, goes to infinity in that direction. Okay. 6 more to go here. Let's go ahead and try one, and then pause the video and try to see if you can do number 4 on your own. Let's set what's inside the absolute value equal to 0. Add 2 to both sides. X equals 2. Now we're going to plug in to the equation and find out this is half of my vertex. Let's plug it in and see what the other half is. 2 minus 2 is 0. Absolute value of 0 is 0. So we're going to go up 1, up 2 from that point. We're going to go down 1, down 2 from that point. And then we're just going to plug these in. So y equals absolute value of something minus 2. Let's see what that is. Plug in a 0. 0 minus 2 is negative 2. The absolute value of negative 2 is 2. All right, let's plug in 1. Y equals the absolute value of 1 minus 2 is negative 1, so the absolute value of negative 1. Y equals, this is 1 because it's 1 unit away from 0 on the number line. Okay, let's plug in 3. 3 minus 2 is 1. Absolute value of 1 is 1. Alrighty. I'm plug in 4. 4 minus 2 is 2. Absolute value of 2 is 2. So we're going to go ahead and graph these points. 0, 2, 1, 1, 2, 0, 3, 1, 4, 2, and I have my graph. Okay, I would encourage you to try number 4 on your own. Pause the video and see how you do. Alright, let's see how you did. Go ahead and take x plus 4, set it equal to 0 to find the left-hand part of your vertex, the x-coordinate. We're going to subtract 4 from both sides. X equals negative 4. And now we're going to plug that in. Y equals the absolute value of negative 4 plus 4, plugging that in for x. Negative 4 plus 4 is 0. Y equals 0. So I know that my xy table should have negative 4, 0 as the vertex. Now let's see what else will be here. We're going to go up 1 up 2 from x, that is greater 1 greater than -4, 2 greater than -4, and then go down 1, down 2 from that x value of the vertex. And let's plug these in and see what happens. Okay, plug in a -6. -6 plus 4 is -2. The absolute value of -2 is 2. Let's plug in -5. -5 plus 4 is -1. The absolute value of -1 is 1 because -1 is 1 unit away from 0 on the number line. Okay, let's plug in -3. -3 plus 4 is 1. 1 is 1 unit away from 0 on the number line. And let's see, -2. -2 plus 4 is 2. The absolute value of 2 is 2. And so I'm ready to graph. All right, -6, 2. -5, 1. -4, 0. -3, 1. -2, 2. And there we have it. Don't forget your arrows. All right, 4 left to go. Let's go ahead and get to work. We're to set what's inside equal to 0. So x equals 0. We're going to plug that back in. Y equals -3 times the absolute value of 0. Well, the absolute value is 0. 0 times -3 is 0. So my vertex is 0, 0. I'm going to go up 1, up 2 from that x coordinate of the vertex, down 1, down 2 from the x coordinate of the vertex, and let's see what happens. Y equals -3 times the absolute value of, let's start with -2. The absolute value of -2 is 2. -3 times 2 is -6. Plug in -1. Y equals -3 times, -1 is 1 unit away from 0 on the number line. So y equals -3. All right, we're going to plug in 1. The absolute value of 1 is 1. And -3 times 1 is -3. Okay, plug in 2. Absolute value of 2 is 2. -3 times 2 is -6. And now we're ready to graph. -2, -6. -1, -3. 0, 0, 1, negative 3, and 2, negative 6. And there we go. I would encourage you to try number 6 on your own. Let's see how you did. Set the x, whatever's inside that absolute value, equal to 0. In this case, x equals 0. There's nothing else to do. We're going to plug that back in to see what y is, the y-coordinate of the vertex. Y equals 1/3 times the absolute value of 0. Well, the absolute value of 0 is 0 times 1/3 is simply 0. So set up my x, y chart, and we have 0, 0 as my vertex. Now I'm going to go up 1, up 2, down 1, down 2 from that point. Well, let's go ahead and try to see what happens when we plug these points in. Well, let's plug in negative 2. The absolute value of negative 2 is negative 2. Excuse me, it's positive 2. One-third times 2. Well, we can put the 2 over 1. 2 times 1 is 2. 3 times 1 is 3. So y equals 2/3. Okay, let's plug in negative 1. The absolute value of negative 1 is 1 because it's 1 unit away from 0 on the number line. 1 times anything is itself identity property multiplication. So we get negative 1, 1/3. Okay, let's plug in 1. Y equals 1/3 times, absolute value of 1 is 1. Y equals 1/3 times 1 is 1/3. And last but not least, let's plug in 2. The absolute value of 2 is 2. 1/3 times 2, put it over 1, 2, multiplying across, and 3 times 1 multiplying across as well. Gives me 2/3. Now, there's a different technique you could have used. If you don't like working with fractions, since we recognize it was the 1/3 there, we could have used -6, -3, 0, 3, 6, and that would eliminate these fractions. But of course, you can go either way. Okay, let's graph this. -2, 2/3, so almost to 1, but not quite. -1, 1/3, so a little lower there. And 0, 0. 1, 1/3. 2, 2/3. If you split this into 3 parts, you'd go 2 of those parts up. And that will do it. Okay, last but not least. Last 2 problems here, a little more complicated. Set what's inside the absolute value equal to 0. Add 1 to both sides. Plug that back in. 1 minus 1 is 0. Absolute value of 0 is 0 times -2 is 0. 0 plus 4 is 4. So my vertex So my vertex is 1, 4. I'm going to go up 1, up 2, down 1, down 2 from that point. So let's see what we can do here. Y equals negative 2 times the absolute value of something minus 1, and then plus 4. Let's plug in negative 1. Negative 1 minus 1 is negative 2. Absolute value of negative 2 is positive 2. Negative 2 times 2 is negative 4. And negative 4 plus 4 is 0. Let's plug in 0. 0 minus 1 is negative 1. The absolute value of negative 1 is 1. Negative 2 times 1 is negative 2. And negative 2 plus 4 is 2. And by this point, hopefully you figured out that if I've done my work correctly, this should be symmetrical. This should be a 2, and this should be a 0. But we want to make sure that that's true. So we'll go ahead and plug it in. Plug in a 2. Y equals negative 2 times 2 minus 1 is 1. The absolute value of 1 is 1. Negative 2 times 1 is negative 2. And negative 2 plus 4 is 2. So we're going to plug that 2 in. Now, you'll notice this has already been symmetrical. If that happens, you can go ahead and say, you know what, this is going to be a 0, because they do exhibit that symmetry. We're going to go ahead and graph this. Negative 1, 0, 0, 2, 1, 4, 2, 2, 3, 0. Okay, go ahead and try to see if you can do number 8 on your own. Pause the video and see how you do. Okay, let's see how you did. We're going to set the x plus 3 equal to 0 to find the x-coordinate of the vertex. X equals negative 3. Now we're going to plug in the negative 3 and see what happens. Y equals 1/2 of the absolute value of negative 3 plus 3 minus 5. So y equals 1/2 onto absolute value of 0 minus 5. Y equals, the absolute value of 0 is 0. 0 times a half is 0. And 0 minus 5 is negative 5. Now we're going to go up 1, up 2 from the x-coordinate of the vertex. We're going to go down 1, down 2 from the x-coordinate of the vertex. Let's go ahead and start plugging in some x values and see what we can come up with. All right, negative 5. Negative 5 plus 3 is negative 2. The absolute value of negative 2 is positive 2. Half of 2 is 1. And 1 minus 5 is negative 4. Let's plug in negative 4. Negative 4 plus 3 is negative 1. The absolute value of negative 1 is positive 1. 1/2 times 1 is 1/2. 1/2 minus 5 is negative 4 and 1/2. Now again, if we've done our work correctly, when I plug in negative 2, I should get negative 4.5 as well to get this symmetry. So let's see if we can get negative 4.5 right here. Plug in negative 2. Negative 2 plus 3 is 1. The absolute value of 1 is 1. Half of 1 is 1/2. And 1/2 minus 5 is negative 4.5. So everything's worked out just the way that I had wanted it to. I have the symmetry that I needed. That means that I had done my work correctly and the vertex is correct. So now this must be negative 4. Okay, let's graph. Negative 5, negative 4, negative 4, negative 4.5, negative 3, negative 5, and negative 2, negative 4.5, last but not least, negative 1, negative 4. That forms the basis for my graph. Now I could end it here, but I'd like to show you some patterns that you can get from these graphs. Let's go back to the original graph that we had done. The number in front here, in front of the absolute value, is a 1. That means the slope is going to be positive 1 over positive 1 to the right of the absolute value vertex. And where's my vertex? If you notice, I can rewrite this. Y equals 1 over 1 onto the absolute value of x plus 0 minus 4. Well, take the opposite of this, which is 0, and then minus 4. My vertex is 0, negative 4. Now I'm going to rise 1, run 1 to the right of the vertex into the opposite, match it to the left of it. That gives me a much quicker graph. Again, here, y equals 1 over 1 times the absolute value of x plus 0 plus 3. Here's my vertex, 0, 3. To the right of the vertex, I rise 1, run 1. And then I match it on the other side, but going the opposite direction. Number 3, you see I could write this as y equals 1 over 1, absolute value of x minus 2 plus 0. Now you have to actually take the opposite of this. So the vertex is going to be the opposite of this, which is positive 2, and then 0. So 2, 0. To the right of that vertex, I rise 1, run 1. And then match it going the opposite direction. Number 4, same thing. Opposite, I say y equals 1 divided by 1 times x plus 4 plus 0. Opposite of this one, which is negative 4, and then this one is regular, 0. So negative 4, 0. To the right of the vertex, I rise 1, run 1. Then match it going the opposite direction to form the V. Number 5, I can rewrite it. Y equals negative 3 over 1 times x plus 0 plus 0. So my vertex is going to be 0, 0. But to the right of the vertex, I rise -3, run +1. And then I match that going the opposite direction to form the V. Number 6, again, y equals 1/3 times the absolute value of x plus 0 plus 0. So my vertex is 0, 0. To the right of the vertex, I go up 1, right 3. Rise 1, run 3. And then I match that, go in the opposite direction to form the V. Number 7, I can rewrite this as well. Y equals -2/1 times the absolute value of x minus 1 plus 4. My vertex is the opposite of this, which is 1, and this number as well, 1, 4. To the right of the vertex, I go down 2, right 1, rise -2, run +1. And then to form the V, I go the opposite direction on the left. So you can see it's just a much quicker way of doing it. Again, y equals 1/2, did not have to rewrite that. The absolute value of x plus 3 minus 5. Well, my vertex is the opposite of this one, and then just that's the y of the vertex. So -3, -5. To the right of the vertex, I rise 1, run 2. Then I go the opposite direction to form the left-hand part of the V. So you can see, the first part of the video I did the long way. The second part, I was showing you the much quicker shortcuts for graphing these two variable absolute value equations in the coordinate plane. I hope you've enjoyed. Thank you so much for watching Crazy Math Productions.